Okay, we're going to have a look at the example where we need to calculate the GM, or the metacentric height, at the critical instant. Critical instant, I should say. I'm going to use what we call the formula that involves the km of the vessel. We can use another formula that involves the kg, but the km formula, I will call it, is slightly more accurate in the sense that it gives a slightly worse scenario for the GM. Therefore, it's on the safe side, you could say. So we're erring on the side of safety. So our vessels, we've got our length between perpendiculars, kg, drafts forward and aft, and we're going to enter dry dock, and we need to calculate the metacentric height. The formula for calculating the loss of GM, if you like, the virtual loss of GM, is the P force times Km over our displacement. So how do we get these values? Well, displacement, we would need our true mean draft. Km we're going to look at in the tables, and we're going to talk about that shortly. P, this P force, we have to use this formula here initially to work out the P force. So to get the metacentric height at the critical instant, we're going to calculate the loss, eventually calculate the loss of GM, and then compare it to our, if you like, our solid GM, and see what the difference is. But before we can do that, we have to work out the P value. When we look at the formula, P is trim times MCTC over LCF. Well, trim is going to be the difference between our two drafts in centimetres. We must put that in centimetres. And MCTC and LCF, well, we can only get those by using the tables, and we have to get the true mean draft to get the values. So, first of all, we get our average mean draft, 5.6, go into the tables and get the LCF. With that, because our draft aft is greater, then it's the true mean draft is aft draft minus the trim times LCF over LBP. True mean draft 5.61. We then go back into the tables at 5.61, get our displacement, MCTC, LCF. Put those into the formula, and remember what I said about trim, we call that 100. 100 times 165.1 over 68.72, and it tells us at the critical instant, the weight of water, if you like, displaced at that critical instance is 240.3. So that force is acting through P. In other words, that 240.3 tonnes has replaced the volume of lost buoyancy. So the weight of water displaced at the critical instance is going to be W minus P, which is our displacement, minus 240.3. It's very important to know that we have to use this value of displacement to now get our true mean draft at the critical instant. So we go in with this displacement, 11,183.7, get our true mean draft. With that true mean draft, we can look up our Km. Because it's not, the Km doesn't change because of a loss of weight, because our weight's still the same. The reason the Km changes is because our draft has changed. So our true mean draft at critical instance, 5.5, Km now is 8.71. We use the virtual loss of GM formula, our P value that we've just got before, 240.3, multiplied by the Km that we've used with the new true mean draft. We must divide that by the full displacement of the vessel, the original displacement, because that hasn't changed. The overall, the full displacement hasn't changed. So it gives us a virtual loss of GM of 0.18. Okay, how do we then find out if our vessel's going to be safe at that instant? Well, our final Km is 8.71 at that instant. Our Kg isn't going to change because, of course, our weight hasn't changed. So the Kg will be 8. So the solid GM, if you like, is 0.71. Let's knock off the virtual loss of GM of 0.18, and we can see that at the critical instant, when the vessel takes the blocks overall, the GM effectively is 0.53. Had that value been minus, then we would be in trouble. So the value of 0.53 means that we're safe at the critical instant. So two potential pitfalls to watch out for there. you must get your Km at the critical instant. In other words, full displacement minus the p-value gives you the true mean draft at the critical instant. Look up the Km, use that value, but you must use the full displacement on the bottom, because of course that hasn't changed.